Right, so 30 years ago, the world was introduced to Netscape Navigator, and soon after SSL 2.0. So around the same time, Eric Young developed SSL EAY, the crypto and SSL toolkit that would eventually become OpenSSL. The export version of Netscape Navigator did not support strong ciphers, or what used to be strong 30 years ago, but SSL EAY did support those strong ciphers. So at the time, I was working for a company in South Africa, and we got approached by one of the big banks. So what they wanted to do is to build a system that can do bank-grade encryption. And what I did is I used that SSL EAY toolkit to build a transparent TLS proxy for Windows. I also built the termination site for the bank. So that was my first TLS proxy. So since then, I've built many TLS proxies. So it would be fair to say that I've been involved and I've seen most of the changes to TLS. So TLS, encrypted client hello, or ECH for short, is one of those major changes. So most of the focus of this conference seems to be on AI and post-quantum algorithms. But we want to highlight ECH as something that you cannot afford to ignore.
Thank you, Roloff. So my name is Arnaud Tadei, and as Roloff was in South Africa 30 years ago, I was in Moscow in the Russian Academy of Science at that time. If you draw a line and compare our journeys, both Roloff and I are at two extremes of that line. So based on this experience in Russia, I was hired at CERN in Geneva. And what you see here is the desk of Tim Berners-Lee. Tim Berners-Lee invented HTTP, and he was my neighbor. So imagine you start your career, the first job you have in your career, and the person who is in front of you is Mr. Tim Berners-Lee. So I had a long career as a solution architect. In 2017, another legend, Mr. Hugh Thompson, becomes the CTO corporate of Symantec and asked me to directly report to him. And what he does, he sends me to the International Telecommunication Union. You may not know it, but you use standards from the International Union every day. X.509 is a recommendation from the study group 17. In last October, I was elected chair of study group 17. So most of my time is not doing proxies, but is doing techno diplomacy. It was a hardcore election. I won it 82 countries versus 10. So I'm a mediator for the UK. As a French and Swiss, imagine the irony. But back to 2018, after our strategy as Symantec collapsed at the IETF on TLS 1.3, I asked Hugh, our RSA chair, the permission to go through all the TLS developers in the company and regroup them. And that's when I met Roloff. And since then, we never left each other. It's like a long partnership together, but imagine how diametrically opposed we are in our careers. So I've seen a lot, but from a completely different perspective, especially because when Tim Berners-Lee created the web, we had a completely different idea of how the world would be. And so that's how I look at ECH, is why is it we've been into where we are today?
Thank you, Arnaud. So I'm going to do a deep dive on the technical details of ECH. And I'm going to do that by asking 4 questions. The first question is, what is ECH? So ECH is an extension to TLS, and specifically TLS 1.3. It does not work in TLS 1.2. So the first message in the TLS handshake is a client hello, and it's sent in the clear. And there's a lot of metadata that you can extract from that client hello message. The major one being the destination hostname, also called the SNI. So ECH encrypts that client hello and all that metadata with a key that is shared through DNS. So not all destinations want to use ECH. So only domains that have a corresponding ECH configuration published in DNS will get that encrypted client hello. So what about domains that do not advertise support for ECH? So you would think that the browser would just not send that ECH extension, but it turns out that's not the case. So the browser will still send the ECH extension, just a fake version of it, called Grease ECH. And the reason that's done is to make it difficult to distinguish real ECH from fake ECH. So we will soon be in a situation where most of the TLS sessions that you see on the internet will actually have that ECH extension. So why would we want to use ECH? It's mostly for enhanced privacy reasons because it encrypts sensitive metadata. But there's also an interesting use case. So if you're a large enterprise and you have a service that you want to advertise where people can use internal services in your company, you can still use ECH and people will hit that public entry point and nobody will know which service you're accessing internal to that company. So the next question is, when are we supposed to see ECH? So the news is that it's already deployed in production and supported by major browsers. So the browsers currently do provide a mechanism to disable ECH. And if you deploy, if you have managed browsers and you deploy explicit proxies, for example, using a pack file, then that will also automatically be disabled. There's currently no mechanism for ECH to function if you use an explicit proxy. So the interesting thing is, yes, it will be disabled, but the browser may still send the ECH extension, just the fake version of it. So who is driving the adoption of CDNs? So it's mostly, ECH. It's mostly content delivery networks or CDNs. The major players being Cloudflare, Fastly, Amazon, and Akamai. And in the next two slides, I'm going to show you why it makes a lot of sense for a CDN to use ECH. So it's interesting to note that about 99.9% of the top 10,000 sites use a CDN. And what that means is we will soon see a lot of ECH on the internet. Probably the majority of the TLS sessions on the internet will use ECH. So the last point is that the ECH specification is in final review, and ratification of that standard is imminent. It's like any day now. Right. So this is a diagram, a very simplified diagram of a CDN before ECH. The arrows represent TLS sessions with the host name of the destination inside the arrow. So the browser looks up the host name through DNS, and then through various alias lookups, eventually, if you're using a CDN, eventually that IP address that gets returned will be the IP address of the closest CDN edge server. So a CDN edge server is a caching reverse proxy. So what that means, it actually terminates those TLS sessions, it extracts the host name that it's supposed to go to, and then creates corresponding upstream TLS sessions to the respective origin content servers. So in case you're wondering, yes, the CDN does have access to your decrypted TLS content. So we as internet users should implicitly trust CDN providers. So any network device on the path between the browser and the CDN Edge server will have access to the destination or the final destination by just looking at the content encoded in the client hello in the clear. So how does this change when ECH is introduced? So keep a close eye on the two arrows between the browser and the Edge server as I advance to the next slide. So in this diagram, the CDN has enabled ECH. So we have the same two sessions from the browser to the CDN Edge server. And the CDN has enabled ECH, so what that means, it has published the ECH configuration for those two sites in DNS. So included in that ECH configuration is a host name. And that's the host name of what we call the ECH client-facing server. That ECH client-facing server will be the termination point for your initial TLS session. And it happens to be, in the CDN case, it happens to be one of the CDN Edge servers. So also included in that ECH configuration is a public key. And that public key, through some crypto, is used to encrypt the client hello. The ECH client-facing server, or in this case the CDN Edge server, has access to the private key. So it has the ability to decrypt that encrypted client hello and extract the final destination. Yeah, in case you're wondering, the CDN still has access to your decrypted content, irrespective of the use of ECH. So why does it make sense for a CDN to use ECH? It's based on the one-to-many relationship shown in this diagram. So you have one CDN Edge server that maps to multiple origin content servers. And ECH does not provide any privacy benefit without that property. If you just have your one origin content server behind your ECH client-facing server, then anybody between the browser and the ECH client-facing server can figure out what the final destination is by just knowing which ECH client-facing server you're going to. So now let's look at some real numbers. So we have two sides. We have the usage and the deployment side. So on the usage side, I actually extracted some real-world metrics. So Symantec has something called the Symantec Enterprise Cloud, and we have a lot of TLS proxies in that cloud. So I extracted some real metrics, and this is a good representation of a large enterprise network. So the disclaimer here is it's a large enterprise network. So if you have a small to medium business or even a home network, the numbers might look very different. And these numbers were captured, I think it was end of March. So this might change on a daily basis as well. So about 21% of the TLS sessions we saw on our network had the ECH extension. And of those 21% with the ECH extension, our TLS proxies decrypted 46% of them. So decrypt in this context means the TLS proxy selectively decrypted those sessions based on metadata from the TLS client hello, specifically the destination encoded in the client hello. So if it was using ECH, the SNI, or the destination hostname in this case, will be the hostname of the ECH client-facing server. If it's using real ECH, not if it's using fake ECH. So as it turns out, only 0.1% of those sessions were potentially, well, we confirmed that it was real ECH. It doesn't mean there was also not some other real ECH, but the mechanism we used to confirm only gave us a number of 0.1%. So the majority of that traffic was using fake ECH. So on the right-hand side, you have some deployment numbers. Deployment means we look at DNS, and we look for those ECH configurations that get published in DNS. So of those, only 9% had the ECH configuration at the time we took the measurement. So we use an internal top 1 million list. We get that from our site categorization technology. So again, that represents a large enterprise network, so the numbers might be very different for a small enterprise. So one interesting observation is that the top 300 sites on our list did not advertise support for ECH, and that includes sites like Google, Facebook, and YouTube. And as can be seen, Cloudflare clearly dominates the CDN market, and almost 100% of the ECH we got from that DNS analysis were sites that was fronted by Cloudflare. So a last point in the section, very important, is that the numbers you see on the slide, we expect those to increase once the ECH specification is ratified, which again will be any day now. So now let's look at the technical impact of ECH, and more specifically, how does it affect visibility into encrypted traffic? So, the obvious impact is that the metadata will be encrypted. So what this slide also shows you is that it did not happen overnight. It was a progression. So the first step was TLS 1.3. So what that did was it started encrypting some of the TLS handshake messages that used to be in the clear in TLS 1.2. Most specifically, the server certificate. So TLS 1.3 took about 4 years to develop, and it had 28 revisions to the draft. So for comparison, the effort to decrypt the last few pieces of the TLS metadata started about 7 years ago, and has already seen 24 revisions to the draft. So clearly, this is a very complex problem. So what we have on the right is the result, with almost no usable TLS metadata left. The one at the top is the ECH public name. That's the public host name of the client-facing server. So all that really tells you is which CDN is using or is fronting that site. And what does that mean for visibility of encrypted traffic? Does it provide new opportunities for malicious actors? So let's take a look at that question. So to answer the question, we have to look at the status quo of TLS proxies in a network security context. So network security policy is based on available metadata. So if you have a TLS proxy, the metadata can be extracted from at the point where you make the decision, typically the TLS client hello. But it doesn't have to be just TLS metadata. It's anything on a network level up to the point where you have to make that policy decision. So for compliance and privacy reasons, the TLS proxies would then selectively decrypt those sessions to scan for security violations, as shown in the diagram. So the top TLS session is decrypted, and the bottom one is not. So in an enterprise environment, those TLS proxies would decrypt the content and send it to the security stack to detect security incidents. And those security incidents would then be reported to something like a security operations center, and that will generate a report, and the report will go to your security team. And that whole process works very well. We have a whole industry represented at RSA that uses what I have on this slide. So let's see what happens if we introduce ECH into the picture. So the impact is dramatic, because the metadata fields that were previously used to make policy decisions are now encrypted. So TLS proxies can no longer selectively decrypt TLS sessions. So if the remaining metadata cannot be used to make TLS intercept, TLS decrypt decisions, then the result is that those sessions will have to be ignored. So your security stack and your security tools will be blind. So this is an open invitation to malware to use ECH for their command and control connections. So on that dramatic note, I'm going to hand over to Arno.
Thank you, Olaf. So with this in mind, let's look at why is ECH a game changer for security. So the first thing we tried to do here, and we did a very, very small zoom on the history of what leads to ECH. If we were to do a proper job to explain the whole history of TLS in terms of the standardization piece, it would take me an hour. I did it, it's literally an hour. So it's a very small version here to demonstrate that ECH, which is the, I'm colorblind, but this is the red part in the middle, is not ratified yet. In fact, since we did the slides, it reached release 24. And this morning, there were 2 last pull requests that were submitted on GitHub and approved, and 1 issue was resolved. So they are just finessing the end of it. But to get there, they had to do a lot of work. And if you look at the start and the status time, you see that, for example, the first requirements, RFC 8744, started in 2017, and it was finished in 2020. Then to achieve that, imagine that when you start the client Hello, you have nothing before you. So they had to imagine a world where there is a new role, the client-facing server, that will hide all the origin servers behind it. Think about it a minute. You need a very strong infrastructure to do that. It's very risky design. Then they had to create a new cryptography. Cannot be symmetric, that's the end goal. Cannot be asymmetric, that's the goal of TLS. So they had to create an HPKE, hybrid public key encryption, at the second line, RFC 9180. But then, as now they have a cryptography to create an encryption model for encrypting the SNI, they have to send it from the client-facing server to the browser. And they decided, it's not mandatory, but they decided to change the DNS for that. So if you go to the DNS now, you're not just going to get example.com will get 1.2.3.4. You will get example.com 1.2.3.4, and you will see new lines coming back from the DNS server, like a resource record. And in this resource record for ECH, we'll have one for ECH that will store the public key the browser needs to create is encryption of the SNI. So these required changes on the DNS. These required DOH. These required many things. So it's just a small version of what they had to do before. So imagine that this extension is not just one tick box that you say, oh, I want the extension. You need a massive set of things behind it. And it's not finished. They are, when ECH will be finished, ratified, there are 4 new drafts that are going to make life even more complicated. So for example, the implicit ECH configuration is actually to find a mechanism to even remove the SNI itself. It will be some kind of another way to get to their objective, that is to hide the SNI. So the other thing as well is that you see draft IETF TLS ESNI, because at the beginning, it was just to encrypt the SNI, not to encrypt the whole client hello. So it's why you see ESNI and not ECH in the name of the draft. All right, so let's continue. So this is going to impact enterprise network security infrastructure. So there are 2 things here that are going to happen. The first is going to reduce your network visibility a lot. And in fact, what could possibly go wrong? A lot of things. You are going to decrease the visibility you have on incidents. It will prevent malware detection and prevention. So For example, if you are not able to say, make a policy if the user goes to smelly.com, in this case, you don't know what is going to happen when you get a download from this site. You cannot use a CAS service to actually do your protection. You will have the issues of data exfiltration. So on the other way around, if you are not able to see the destination, if the user goes on box.com and you have a policy that says, if user goes on box.com, make sure you apply DLP. Well, now you cannot. You will have issues on TLS decrypt, selective TLS decrypt will not longer be possible. So the trick that Roelof was showing, that you only need to look at the TLS SNI that is of interest for you. Now you cannot. So it's going to create a massive compliancy risk for your organization and possibly massive cost. We just got a hint when a few banks in the US, I think 2 years ago, were fined 100 or 200 million each because they could not show the traffic on WhatsApp on their trader site. So imagine that if you go to your company and say, sorry, I cannot decrypt anything. Imagine when the audit happens. That's the type of thing that is going to happen. So let's recap a bit. So we have here an extension that is not just a little extension. It hides a massive infrastructure and a massive design behind it. You are going to have a new encryption that was set up. You have a new role, the client-facing server. It is entrusted to create a configuration. It will publish the keys to the DNS server perhaps every hour. The DNS server will have new design. It will look like more a big directory service. It will have service bindings and resource records that will be downloaded to the client through DOH or maybe oblivious DOH or other technologies to mask the entire chain. So you are not in front anymore of one typical approach that I have a problem, I put a box, finished. It's not a self-contained stack anymore. You are facing a major system problem. You're going to have a whole ecosystem to deal with. And the first issue you are going to have in your organizations will be the siloing of your teams. Let's be honest, we speak with customers every day. We see how these joints are the DNS team versus the security team versus the network security team. And that's the first problem you have to face. Get your teams to work with each other to understand the problem. Much bigger organization issues. So I don't know if there are government people in the room, but there are other issues that will happen at policy and regulatory level and compliancy issues. So these are considerations for the community to take note of. All right, so the issue for governments is that they confuse inspection with interception. It has nothing to do with lawful intercept. The problem we have here is very simple. In the general case, I am a user at home. I have my encrypted connection to my site. Life is good. I should not be able to be broken. Let's say it's not easily breakable. But when it comes to critical infrastructure, so say I'm a government agency and I'm a government and I see a critical infrastructure, encryption is an attack vector. So we could see in ransomware attacks that the cyber criminals are using encryption today, not even with ECH, to actually hide and do what they need to do. So no, encryption does not equal security. Big mistake that some people have done in the past. So for organizations to decrypt and inspect the traffic, this is a very common security practice. It leads to an entire market to manage these issues, but as well it provides valuable intelligence and response capabilities for security teams. So again, it has nothing to do with lawful intercept. Decrypting and inspecting the traffic matters because for compliancy reasons and security reasons, it's all about don't let the bad things come in and don't let the good things go out. That's what government people should think about when they look at that problem. So why are we in this situation? Well, it was really an enigma, especially for when we looked at that back in 2017 when we did all of that. There was here a situation where when Snowden broke, it shocked the community. And one part of the community decided to make everything possible to encrypt to the maximum of what they could. The first thing is they issued RFC 7258 in 2013, where basically they said pervasive monitoring is an attack. The problem is that in 12 years, it moved from this position to an hardening of attackers' definition. In this definition, even a network security device is an attacker. Think about it a minute. We are here to defend, and now IETF thinks that we are attacking the protocol. In fact, it's true we are attacking the protocol because they don't give us a way to actually help the security. So the issue is not just ECH drives the whole ecosystem. ECH is part of a much bigger context that people don't see. If you take a step back, it's the last piece of a much larger puzzle. Consider TLS 1.3, DOH, or we use DOH and others. The DNS now participates to the solution. But it goes as well with the problem that is causing to the internet principle. The internet principle was an end-to-end principle. We get all our IS numbers, our IS segments that are able to get the traffic from one point to another one. But because the CDNs now claim their fair share on the matter, this distorted by gravitation effect this end-to-end principle to an edge-to-edge principle. And so there is this economic context behind the scene that is hitting here. Transport and HTTP will be impacted, that's very clear. And anonymity, the issue behind is that if you want to hide a massive number of origin servers as to make sure they are not visible, it's not the only thing that will happen. You are going to see more things, for example, how to hide IOCs. So the CDNs are claiming another space, the space of multi-secret party computing, to make sure that you can't access an IOC. You can have the answer, but you don't have the data. Think about it a minute. So in this intention, there are more dimensions at play. So if you just look at QUIC, QUIC actually is not running in the kernel. It's an application level. Human rights wants security at content delivery network, not at infrastructure layer. That's what they are pushing for. It's an absolute dogma. Even having a scanning at the endpoint is not acceptable for them. So we see that we are moving from an infrastructure approach to an application approach, driven by CDNs and browser makers. And the most important, that's not just by chance. It's an absolute intention to fail active and passive network security. Right, so to read the situation took me quite some time, and in fact, when Hugh Thompson, our RSA chairman, was my boss, he asked me to look at the problem, taking into account 4 things. He said, Arno, please look at that problem, but you may need the help of an anthropologist, an ethicist, a legal person, and a technologist. And at that moment, back in 2017, I could not understand what he meant. It took me a long time to put all the pieces close to each other. So in fact, when you design something, when you have an anthropology, you can normally start by the anthropology, go to ethics, go to legal, and go to technology. We engineers only look at technology. We have not been tried correctly on the 3 other parts, so we take it like a river of unconscious behind us, right? So if I have to design a bridge, I will think about the bridge must be designed in wood or in steel or in concrete or whatever. I forget the other steps. When there is no anthropology, which is the case where we are, there is no user experience. I mean, we have IT since 50 years, the web since 30 years, social networks perhaps since 15 years, and AI since 2 years. It's nothing at the scale of humanity. So what we missed here is the fact that when people are in front of this problem, they have to do the reverse path. What technology allows me to disable or enable as legal frameworks? For each node, which ethics I can enable or disable, and for each node, which anthropology I can enable and disable. And some people knew that a long time ago, way before us, and they made a choice for us. The choice is that they ended up with a very narrow model of the human being in this whole chain. And that's the problem where we have a bottleneck now. Because by doing this, when 30 years ago we designed the web, it was absolutely not our design. We were on a completely different branch that happens today. So something happened, and now it's disturbing the people who put it in place. So we are wondering if a way to fix that could be to actually introduce the concept of subcontext. Do we have a subcontext for channel and protection, enterprises, and so on? So What we did with a few of us, I know Andrew is here in the room, 4 of us, Paul Vixie, if you know Paul, Andrew, David Wright, and myself, and my dear Simon, who passed away. We created an internet draft called ECH Deployment Considerations because it's not a win-win situation. ECH will make that some communities will lose. Channel 9 protection cannot work, education cannot work, public network cannot work, and enterprises cannot work anymore. So we have a draft. These had an impact because it was a big, big battle, a very violent and toxic battle in the IETF. But at the end, the reason why you will see a section called ECH Deployment Consideration in the ECH draft is because we did this one. This one is not settled, and we will try to settle up, to establish it in IETF 1, 2, 3 in Madrid in July. So implications for national and regional administrations is that when this is going to happen, it's going to put a lot of pressure on sharing requirements and on sharing threat intelligence. I think out of this list, the most fascinating one is the problem of massive resiliency. Imagine when you have a CDN that owns 70% of the market, forget security for a minute. If something happens there, the whole traffic will be stopped. But think a minute as well about the sovereignty issue it creates. So consider an EU perspective, for example. That's going to be an interesting position. This is discussed among select players like CDNs, browser makers, human rights, critical infrastructure. Are you part of it? So if you're a policymaker and you're not part of it, you're going to suffer. Example, DORA, the Digital Operational Resiliency Act of the EU for financial institutions. Article 1, Clause 1 is about network security and information security. So you start with something that you cannot do because ECH will prevent. Just think about the paradox. All right, so some suggestions for administrations: study the problem in full depth. Don't neglect it. Don't think it's too complicated or it's not for you. It is for you. Consider the impact for all your regional constituencies, member states, critical infrastructure, financial entities, and consider the impact beyond security. Resiliency, centralization, market dominancy, trustworthiness, sovereignty. So that's our summary. We're getting to the end. Please, Rolf.
Let's rewind to that one for a second. So the IETF engineers that worked on ECH developed a solution to a problem that seemed impossible about a decade ago. So ECH is actually a great achievement. It's a great technology. And I'm sure most of the engineers working on that problem had noble intentions to enhance the privacy for internet users. So unfortunately, the use of ECH is at odds with network security, at least between the client endpoint and the security stack that is supposed to detect incidents. So what should we do? We'll break it up into 2 parts. The first part is what should you do in the next few weeks. First part is start by forming a strategic initiative at your CISO level. So ECH will impact all cybersecurity, and implications must be disseminated through your whole organization. So Arnaud was talking about those silos. You have network team, and you have security team, you have the DNS team. They don't talk to each other. Make sure you start at the CISO level, so that you can have all those teams talking to each other. And please, please, do not keep this to yourself. Please go out, share it internally in your company, share it with your peers in the industry, share it with everybody that works in your industry. So instruct your security and network teams to confirm the presence of ECH on your network. So not just confirm, make sure you have an infrastructure set up so that you can do this on an ongoing basis. So if you start making some decisions about ECH, you want information or data to make your decisions with. So you have to set up an infrastructure to be able to recognize and detect ECH. And then the easiest thing you could do is for your managed endpoints to disable ECH. That's very simple. The browsers will give you knobs that you can change to do that. It's not just browsers out there. There are multiple applications that use TLS. So disable those as far as the applications will allow you to do that. And lastly, configure your TLS proxies to decrypt TLS sessions if you detect that it's going to a ECH client-facing server. So what that would do is, in the specification, there's a mechanism built in. If you decrypt that TLS session, let's call it legitimately, that will automatically disable ECH. And the major browsers currently have a mechanism where if they detect that you have disabled ECH, they will actually fall back and create a new session that will not use ECH.
So, of course, it's not as simple as that. That's why you need to consider a longer-term perspective. For example, yes, you control some of your devices, but you don't control bring your own device, you don't control some applications, and you don't control the bad guys. They don't play by these rules. So in the next 3 to 6 months, you need to evaluate the impact of ECH on your current network. And the most important, these should be a joint discussion between your network DNS and security teams. As well, engage your legal department and regulatory compliance officers, because they will need to be engaged there when you will have to decrypt certain pieces there. The other thing that is much a broad implication is observe the paradigm shift from infrastructure to application layer. There are strong forces now that are forcing you to move away from the infrastructure security because they want you to use the browser and they want you to use the DNS. Engage your security stack vendors. You could perhaps be surprised by what we have to say. Back to the application layer approach. Yeah, it could be a solution, but nothing is a panacea, right? If some people have a problem with man in the middle, I would contest that there is another problem which is called man in the browser. When you have a man in the browser attack, the only way is to have a third party that you cannot trust to help you. I will let you think about it. And finally, we have a few resources, and I think that's it.
That's it, yeah. So we are open to answer any question. Oh, you can rewind to the resource. Okay. So let's leave it there. What happened to the deck? There it is. Okay.
Sorry, I have a question.
Sure.
Kirsty Payne. It's really good to see this presentation. I think, like you said at the start, it's a problem that you can't really afford to ignore. So I think many people will be surprised by the profound implications that this could have. So how would you recommend assessing this against other security priorities? You know, CISOs have a lot on their plate. You said at the CISO level to form an executive strategy. How would you balance it, given how crucial we know security operations are, how crucial this practice is? What recommendation could you give in terms of prioritization against other CISO priorities? Thank you.
Yeah, I can quickly start and you can...
Yep, good.
As I just have one sentence. It's very important, but it's not very urgent. So, I don't know.
Yes, I think this is, it is important. It is crucially important that people anticipate, because the problem is that when it will be there and you are not prepared, that will be impossible for you to manage. So the second thing that we observed, because I think I had to present that to 70 customers in the past 2 years, is the psychological impact. So for 70 times, I spoke with CISO teams, and what I observed was the cycle of emotion. And it starts with denial. Oh no, it's not possible. Then it goes to angriness. What are you telling us? Then it moves to fear. What are we going to do? And then it goes to silence, consideration. I've seen that 70 times in a row on, I'm telling you, 150, the top 150 fortunes. So the problem is to break this impression that the vendor will fix it. Well, no. You have to onboard that for yourself and understand the implications, because when the auditor will be there and say, wait a minute, what is this 5% or 10% of the traffic you are not looking at? What are you going to say? Today is very small, but we've seen the TLS 1.3 progression. TLS 1.3 won the market in 3 years. Yeah. So if you apply the same with the CDNs and the browser makers on the top 10,000 sites, just imagine how fast it could go. Hope it helps.
Hi, thanks for the presentation. Unsurprisingly, I agree with pretty much everything you said. I think one comment rather than a question is that if you look at the extent of the use cases that are covered in our deployment considerations document, they cover a vast amount of the usage of the internet. The big issue is that hardly any enterprises are present in the standards bodies. So I guess my comment is it will be fantastic to have people here that think this is important to at least pay attention to what the standards bodies are doing and where possible to actually participate. Because otherwise the $200 million fines that you mentioned to those banks 2-3 years ago, with things like NIS2 and DORA and other regulations, that will be applying to a lot more companies in a lot more sectors imminently as this is rolled out. So really it's a call to action to enterprises to engage with the standards bodies, because otherwise it's going to be a very costly exercise as ECH is deployed.
I have a comment on that. So it comes back to what we said. ECH is now a system. It's not just we as Symantec focus on TLS proxies and Infoblox focuses on DNS security. You have to combine those two. You have to build relationships with DNS vendors and network stack TLS type vendors, and those two have to agree that they should both go to IETF together as one unit.
Yeah, if I may add, Andrew, the difficulty needs to be put in another context is that industry on the west side forgot standardization like 20 years ago. So we have a massive industry engagement issue in general. So it's not just about ECH, it's a general issue that, as I said, if I say study group 17, nobody knows. If I say X.509, everybody knows. But people don't recognize that this is a process. And they very often confuse, oh, but we can fix it in open source. They don't get that open source and standardization are two different things. Because standardization is a process of consensus with very specific rules. And that's something that the industry on our side completely forgot. Because the cycles of our industry are, 2 years, if I would be cynical, short-term, mid-term, long-term, a week, a month, a quarter. So we are not in the right thing. So I work a lot in the ITU with China and other countries, and the Chinese have taken a very long-term shot at that. They learned the lesson that we gave them 20 years ago, and now they apply the same lessons to us. And they are doing the job. It's not they have a problem, we have a problem. So I think that there is here something that is a much deeper problem to manage. But when you speak specifically about this one, I managed to get a few customers that suddenly started to realize and do their best to participate, but they are not used to do, they don't have a budget for that, even when they want, it's hard. Because 20 years ago when you were asking, oh, I need this amount of money to go to IETF or ITU, oh, no problem. 10 years ago, the budget would be divided by 4. Now the question coming from your manager is, what is the IETF? That's where you are.
Yeah.
Educate your leaders.
So to add a question about practicality of how to look at this. So when DOH came out a while back and ISPs were encrypting DNS requests, we had to make changes on our security controls to make sure we could see those requests and not allow DOH. Would you look at this the same way with how you would try to configure some of those controls to bypass ECH?
Yeah, in some sense, DOH and DOT, and those are actually a lot simpler.
Yeah.
Because especially in the enterprise environment, you have a company like Infoblox, and you actually have agents installed on your managed devices that can trust the certificates for those DNS resolvers. So the traffic is flowing through your infrastructure already. For ECH, we actually do not currently recommend that you try and decrypt ECH on the internal side. We do recommend that you use ECH, it's a great technology, on the upstream side. So that's from your edge to the internet. So yes, they have similarities, but I would argue that ECH has a potentially much more intrusive impact on our industry.
I think we have one last question because we need to stop then. Okay. Okay. Then this is the end.
Is that? Oh, okay.
Thank you very much.